Hi, this is Mr. V, and in this video we're going to learn how to use the sine ratio to determine the side lengths of a triangle. Alright, so we've looked at how to do this with a tan ratio, and you'll find that using the sine ratio is very similar to that. So we'll go through this a bit quicker than usual. So we want to find the hypotenuse of the following triangle. So we want to know what our hypotenuse is. So we'll mark that as C, just like we do in our Pythagoras examples. So we want to know the hypotenuse. We know what the opposite side is. So we're going to use sine. So sine of my angle equals opposite over hypotenuse. Let's fill in the information that we know. We know the angle, so we know that we have sine 35.6, and that's going to equal our opposite side, which is 4.28, divided by our hypotenuse, which we don't know, so we'll just leave it as C. Now we've seen an example like this in our tangent function. So we know that to solve this we have to first get rid of divide by C to get C times sine 35.6, and then divide by the sine 35.6 to get rid of it, to get C equals 4.28 divide by sine 35.6. If you want a shortcut from here to there, that is generally acceptable. Calculator, 4.28 divided by sine 35.6, close bracket, equals 7.35, so we'll round that up to 7.4. So our hypotenuse is 7.4 meters long. Great. Now we have another example over here, and in this case we're not given the triangle, so we're going to have to do some modeling before we can solve. So modeling simply means drawing a diagram or drawing a picture of the situation so that we can then solve it using known methods. We've got a train traveling 2 kilometers along a sloping track. The track is at an angle of 8 degrees. Through what height does the train rise? So the way I'm reading this question, we've got a slope coming down, and that slope is 2 kilometers long. The track is at an angle of 8 degrees, so if we draw in a horizontal line, this angle is 8 degrees. And we want to know through what height does the train rise, so we're interested in this height here, h. Now because we're doing this to the horizontal, and this height is definitely going to be vertical, this will be a right angle. That's how we've set up our problem, that's how we've modeled our problem. And now we have a triangle that we know how to solve. So we've got a triangle. We've got two sides, one of which is known, one of which is unknown, and we've got an angle that we know. So we can solve this using trigonometry. And you'll have guessed it, we're going to use sine here. Sine of our angle equals opposite over hypotenuse. And we know our angle, it's 8, so sine 8 equals our opposite side, which is our unknown, h, divided by our hypotenuse, which is known, it is 2 kilometers. We'll have to rearrange that to get our unknown by itself. So divide by 2, we're going to multiply by 2. 2 times sine 8 equals h. And that's an equation that we can just put on our calculator. So I'm taking my calculator. 2 times sine 8, no need for inverse sine this time, equals 0 point, and we'll go 2 decimal places this time because it's less than 0. 278, that will round up to 0.28 meters. That's wrong. It'll be kilometers. So 0.28 of a kilometer. And if you're like me, you don't like that, so I might just change that to meters by multiplying by 1,000. Take my calculator again, I've still got the number there, times 1,000. So that is 278, sorry, 0.3 meters. Okay, watch out with those units. Even a master like me can make those mistakes pretty easily. And that is how we can use the sine ratio to find the side lengths of a triangle, plus a bonus how to model a worded question.